Hello and welcome guys. So let's continue from here. So we have in the last video we have done this importing libraries and we have successfully imported the data set, and we have also performed data pre-processing. From using this we have converted this string values in the numerical form, and we have also splitted the data set into training set and test set. And so we are done, and we have now the next phase is feature scaling. Okay, so what we have to do in feature scaling. So if you guys are new to this video and you have not watched my previous video, so I recommend you to watch that video so that you can link that and you figure out what we are doing here. Okay, so in my last video I have done all this. Okay, I have explained in a very detailed manner. So what I have done in the last video, I will explain in brief. So first of all, we have imported the libraries. These all are the required libraries. And then we have imported the data set, and we have figured out what is the data set and how we are doing this. -1 indicate the last element of that day of the index of that data set. So we have used the property of string slicing to make this and to separate the x values and y values. I've explained all this in very detailed manner in my last video. So after that I've done this training and splitting the data set in training set and test set. This is the label encoding phase. Okay, and what's next? So we have to perform here feature scaling. So why we are doing so? Because the variation of the values are very large. As you see here, some values are in 1, 2, 3, 4, but some values are 70, 40, 50, 60, 80, 90. So there is large variation. So there is very difficulty in identifying the relationship between the features. So that's why we have to plot, because overall machine learning algorithm will going to plot and check the characteristic and find out some correlation between the features, and then it will identify how these values depend on y. Okay, so to make the computation easier, we have to perform feature scaling to convert all the data to convert all the values of that feature in a definite range, so that the computation time will decrease. Okay, so for that we are performing feature scaling. Okay, so to perform feature scaling, first of all let's import from sklearn. We have to use from sklearn.preprocessing. Okay, so from sklearn use preprocessing and import here, import standard scaler. Okay, we have to use standard scaler, this one. Okay, so import standard scaler class and define one object standard scaler and give here this is the instance of this class. Okay, and what we have to do, we have to perform feature scaling only on x train and x test, because these x values are only having very large variation. Y is just 0, 1, so we are not interested in performing any feature scaling on y, because we have to classify the result in the form of 0 or 1, whether the value is 0 or 1. Okay, so it's a classification problem where we have to give our output in the form of yes or no, 0 or 1. That is 2 category. So that's why we don't need to feature scale y values. So we are only interested in applying feature scaling on x values. So let's pass here. First one is x test. Sorry, first one let's pass here x train. And what is second one is x test. Okay, these are all the x values. Okay, and pass here sc denotes that standard scaler object, and pass here fit underscore transform method. So use fit underscore transform and give here inside this, give as parameter as x train. Similarly do here x train dot fit underscore transform. If you see the symmetry of machine learning, then you will see that everything inside pre-processing phase is similar. Same we have done above. See here we are also defining the class, and we are applying this fit underscore transform to transform this in this form. Okay, to transform this string value, to encode this string value in numerical form. Okay, so similarly we have also defined here object and applying this fit underscore transform technique to transform our data set in a definite range. Okay, so if you run this, and let's print here xtrain and see what's the values. Xtrain, print here xtrain, and you will see the values is in decimal form as above. If you have seen here, it's 71 something like that. Okay, but here values is 1.7, 0.5. that is, the values are very close to 1 or 0. Okay, so these are the very closed values, so we can easily plot the characteristic of this data set. So, and it's easy to find out the relation between the features of the data set. Okay, so that's fine. If we print here x test, then we will also see the value something like this. Yeah, this decimal values. Okay, so that's fine. So we have successfully completed all the pre-processing part, in which we have cleaned the data set, and now the data set is ready to go in the training phase. Okay, so let's define one entry here. Let's give here training data set. Okay, so this is training data set, and let's give here so we have to perform here training. So we will perform the training on different machine learning algorithm, and we will find out what we are getting. So first of all, let's start with logistic regression. So first of all, I will show you how we can train with logistic regression machine learning algorithm and how much accuracy we are getting. Okay, so first of all, let's run here from sklearn. From sklearn dot linear model, we have to select linear model, import logistic regression, this one. Okay, and type here model underscore logistic. This is logistic model, so I'm typing here, I'm defining logistic model logistic is equal to logistic regression. I'm defining the class logistic regression. Okay, so this is an instance of the class. Okay, and what I am going to do here, model underscore logistic, and just write here dot fit. We have to fit that curve. We have to apply here curve fitting. So write here model logistic dot fit, and type here x train, and second one is y train. Okay, why y train? Because x is our independent variable and y is our dependent variable. Okay, so we are performing fitting by using this, so that all x's value is defining y. So we are doing curve fitting and find out the relationship between them. So let's run this. So model has run successfully, so we have to test this model also. So let's test this model. So we have to test this model also. So let's define here one entry as testing accuracy. Okay, and just import from sklearn dot matrix. Import accuracy score, this one. Okay, from sklearn dot matrix import accuracy score, and before printing accuracy score you need y predict also. Y predict underscore logistic. What is the predicted value under logistic? Y predict dot logistic, and pass here model logistic dot predict. Okay, model logistic dot predict, and in prediction you have to pass x test, because we are testing our model on test set. Okay, so pass here x test, and it will give you y predict logistic. Okay, if you run this, you successfully run this, and how we can choose the that type here accuracy score, and pass here first value as y test, because we are testing, this is y test is original value. Okay, original value of this x test. Okay, for this x test, what is the original y? For these are the parameters which are deciding this y test. Okay, if you see in this excel file, this is y test. Okay, this is y test, and these all are the x test. Y test is almost 20% only. After that, everything is training set. So among this data set, 20% of the data is this, from here to here is x test, and this one is y test. Okay, so for that we have to pass here x test, this is our predicted value, and this is our actual value of that test set. Okay, so that's why we have splitted the data set in training set and test set, because we have to compare the original value with the predicted value. So like that we can identify the accuracy. Okay, to test the accuracy we have to compare the original value and predicted value. So this is our y test, is our original value of the test set. On test set we are going to do all the testing process. Okay, so that's why it's named as test set. Okay, and next one is y predict. We have to pass here y pred underscore logistic. We have to pass logistic. Okay, y pred underscore logistic we have to pass. If we run this, then you will see the accuracy. So this model is giving 83% of the accuracy. Okay, so this logistic regression model is giving 83% of the accuracy. Okay, so similarly we have to find the accuracy of each machine learning algorithm. Okay, so this is about logistic regression. So similarly we have to perform for other machine learning algorithm also. So let's use support vector machine. Okay, so let's use support vector machine. So use here SVM. Okay, so for SVM, okay, so if you have no idea how I am using this, if you stuck anywhere, what are the code and what is the class for each and every machine learning algorithm, then you can just go on scikit-learn API, and you can see that from here. Type scikit-learn and open this link, first one, and just go here in API section and just Control F and type here SVM and search. Okay, so this is support vector machine. From here just click here support vector machine and you will find out this, and you have to use this SVC because SVC stands for support vector classifier. So just go here and you will see everything. So I am using here sklearn.svm we have to import, and from svm we have to use this svc class, and svc class consists of these all are the parameters. C is equal to 1.0, kernel is rbf radial based function, this degree is equal to 3, gamma is equal to scale, coefficient 0 is equal to 0.0, shrinking is equal to true, probability is equal to false, tolerance is equal to 0.001. These all are the parameters which will decide this SVC class. Okay, and these are all the introduction, these all are the values of that parameter. What is this C? C is regularization parameter, and kernel is linear, polynomial, RBF, sigmoid, pre-computed, and by default it take radial based function. Okay, so these all are the parameter which you can change also by just writing this kernel, and you can modify this as by default it's RBF. You can change this to sigmoid or polynomial or linear according to your data set. Okay, you can modify this also. Okay, so from here you can play with this and you can change the parameter and see on which parameter or model is giving a good result. Okay, so something like that you can use. Okay, so let's write here from sklearn dot svm. As you see here, from sklearn dot svm we have to import svc. Okay, sorry, svc. And what we have to do here, we have to choose here model underscore SVM. Okay, so this is SVM model. Okay, this is logistic model and this is SVM model. And take here SVC, just pass empty. You can also pass these parameters if you are interested in changing the value of parameter, then you can pass here on these parameter or simply pass this one, no problem. Okay, simply you can pass here. By default I'm interested only in by default value, so I'm not passing any value. Okay, so similarly you have to do here also. So do here model SVM, model underscore SVM dot fit. You first of all we have to perform fit, and same thing we have to do, just pass here x train y train, sorry, x train and y train, because we have to do perform training process on the training set only. Okay, so for that we have done this. Okay, so let's run this. Okay, so model has successfully run, and if you are interested in predicted value of that one, so just copy this and paste here and change the model. So this is SVM, and this is our logistic to SVM. This is our y predict SVM, and this is the model SVM which we have defined here, and we have predicted this X test for SVM also. Okay, so we get, so let's write here logistic SVM, logistic accuracy, logistic underscore accuracy. Just write here logistic accuracy. Okay, now we are interested in SVM accuracy, SVM accuracy. Okay, so for SVM accuracy, just write here accuracy score, accuracy underscore score, and type here y test, and second one is y predict that SVM by using SVM. Okay, so if we run this, model has run, and you can print here SVM accuracy, SVM underscore this ACC. This is a variable which contain the accuracy of a support vector machine. So in support vector machine I am getting this one. Okay, and if I print logistic, if I print here logistic accuracy, so print here logistic underscore accuracy, and if you see here it's 83%, 83.69%, and SVM accuracy is almost 86.41%. so SVM is giving a very good result. Okay, so similarly you can test on another model which is k nearest neighbor. Okay, so to know about k nearest neighbor, what is k nearest neighbor, you can just go here and go to API and just type Control F and print here k nearest neighbor, k neighbor. Okay, so this is k neighbor which we have to use. This is k neighbor classifier, k neighbor classifier we have to use. And how we can use this, from sklearn.neighbors we have to import this k neighbor classifier class, and these all are the parameter which you can choose. N neighbor is equal to 5, 6, 7, 8, which you want, you can select here from here, and you can also modify the parameter if you are interested in and check the values. So to implement k neighbors, right here from sklearn.neighbors import k neighbor, this one, k neighbor classifier. Okay, and type here model underscore k neighbor, same thing, k neighbors, and write here k neighbor, define that class k neighbor classifier, and you can also write the values if you are interested in something like n neighbor is equal to 5 you have chosen. So right here, okay, from here n neighbor is equal to, let's take 8. Okay, and then model underscore k neighbor dot, you can do fitting because we have to perform training. X train, take X train, and second one take Y train. Okay, so perform fitting. Oh sorry, here double D we have taken. So this is done on neighbor is equal to 8, and you can simply write here y predict also for this. Y predict dot k neighbor, you can choose k neighbor is equal to model underscore k neighbor. You have to predict X test. So this is a y predict for k neighbors, model underscore k neighbors dot predict X test. Okay, and now we have to calculate the accuracy of this k neighbor. So let's write here k neighbors underscore accuracy. Okay, and write here accuracy underscore score, and write here y test, and second one you can choose your y predicted, y pred underscore k neighbor. Okay, so this one logistic. Okay, so this is done, and you can write here print k neighbor accuracy. Okay, let's print here, and you can see. Okay, so k neighbor is giving 84.78% of accuracy. Logistic is giving 83. The best model is still SVM, which is 86.41%. Okay, so k neighbor is done, and now the next one is decision tree. Okay, so let's test on decision tree. Okay, so how you can use that, you can also check from here if you are interested in. Okay, let's write here decision. So this is decision tree. Okay, so this is we have to use classifier algorithm. So let's write here. So from sklearn.tree we have to use decision tree classifier. Okay, so let's write here from sklearn sklearn.tree import decision tree classifier. Okay, and type here model underscore tree you can use, and type here decision tree classifier. Okay, just pass here this one, and you can directly fit your model underscore tree dot fit you can use, and pass here X train, second one is X Y train. Okay, so it's doing, and you can also change the values from here, like you can you can change the value, maximum depth of the tree, what you want. You can also change the parameter of this value. Okay, so decision tree classifier is also trained, and you can simply use here ypred underscore tree is equal to ypred underscore tree is equal to model underscore tree dot predict model underscore tree dot predict. What for what we have to prediction is done on X test, so we can use here directly X test. Okay, so model underscore tree dot predict X test is done, and we have to store the accuracy. Decision accuracy is equal to accuracy underscore score, pass here y test, and second one is y underscore pred underscore pass here tree, accuracy score y test and y pred underscore tree. Okay, so this is done. And now let's pass here print decision tree underscore accuracy. Okay, so let's check its accuracy. Oh, so decision tree is giving 75% of accuracy. So it's very low. Still SVM accuracy is highest. Okay, so similarly we can also test it on random forest. Okay, so let's write here random forest. This is the last. We can use random forest. So from sklearn dot ensemble, similarly you can use from sklearn dot ensemble import random forest classifier, random forest classifier. Okay, and write here model underscore random forest, random model underscore random is equal to random forest and classifier. Okay, random forest classifier. Okay, now what we have to do, model underscore random is equal to model underscore random dot fit you have to do, and write here x train and y train. Okay, model underscore random dot fit x train and y train. Okay, so random forest classifier is also trained. Let's write its accuracy. Let's write its predicted value. So let's store the predicted value underscore random dot predict we have to do, and predict it on x test. Okay, predict it on x test. Let's write here random accuracy is equal to accuracy score same y underscore test y underscore pred underscore random. Okay, that's done. Y underscore random, and let's print its accuracy also. So let's write here random underscore accuracy. So random forest is giving accuracy of 85.32%, and we can also increase. If you go here and search for random forest, if you go here and search for random forest classifier, then you will see that by default the number of n estimator is 100. Let's change the n estimator and see. I think it will take a lot of computation, but let's try to improve it. From here, right here, n estimator is equal to up to 150. Let's write 150 and see if there is any accuracy is increased. 85 we are getting. Oh wow, we are getting now 86.41. Random forest is approaching. Let's change to 200. 86.41 we are getting only. Okay, so up to 86.4103. I think the same accuracy we are getting here also. Wow. Random estimator is equal to 200 we have taken here, and everything else is fine. There is no issue here. Okay, model underscore random, fine, and random accuracy we are getting here yped random. Okay, so this one we are getting. We can change it to 200, 250 if we see any changes. No, we are the accuracy is decreasing, so up to I think 150 is fine. Yeah, 85.86. Oh wow, we are decreasing the accuracy. So up to 200 is fine. Wow, we are getting now 86.95 of accuracy. Great. The model is giving 86.95 of accuracy. Okay. Yeah. So we are done here, and there is one more model which I will tell you can use, and that model is XGBoost. So let's test it on this also from XGBoost. So from right here from XGBoost, we have to import here XGB classifier. Okay, from XGBoost we have to import here XGB classifier, and write here model._xg is equal to model_xg is equal to XGB classifier. Okay, and write here model_xg dot fit model_xg dot fit, and write here x train comma y train. Okay, x train and y train. Okay, so this is done, and write here also y predict of xg, y pred underscore xg is equal to model underscore xg dot predict, from model underscore xg dot predict use x test, from model underscore xg predict x test. Okay, and at last write here xg accuracy equal to accuracy score of this model, accuracy underscore score of this y test y underscore pred underscore xg. Okay, fine, let's run this. So it's run successfully, and if I am printing here xg underscore accuracy, and let's see what we are getting. So we are getting 85.32%. Still random forest is high. Random forest accuracy is more high. Okay, so we are getting, okay, so random forest accuracy is fluctuating, I think up to 250, I think. Let's start from here, then we will see, because we have run this multiple times, so random forest accuracy is increasing or decreasing, because so we have to run from here, so then we will get the right result. Okay, so let's run from here, because random forest accuracy is fluctuating due to multiple running of that cell. Okay, let's run this. Yeah, everything else is fine. Yeah, so we have run this one, XGBoost we have run, and last one. Okay, so we are getting the accuracy of 86.41% in SVM as SVM. So support vector machine is giving a highest accuracy. So this is the best machine learning algorithm for this project. Okay, so SVM model is the best model. Okay, so we have tested accuracy on different machine learning algorithm. Okay, so you can write here testing accuracy on different ML algorithm. Okay, so everything else is fine. So we have successfully built this, and the last phase is to find out, to plot the graph and find out the accuracy and do a single prediction also. So this one we will continue in the next video, in which we will I will plot the bar graph of each and everything, and also I will show you how we can do a single prediction. Okay, suppose we have a random data of one person and we have to predict whether the person have a heart disease or not. So we can also do going to do that one also. So we will continue this. So thank you guys, thanks a lot for watching this video. We will continue in the next video.